Okay, so in this video, we're going to be talking about how to find the equation of the tangent line that passes through the point on a curve. So you can see that the curve that I'm dealing with here is going to be a quadratic. You can see that right here, f of x, okay? So we have to talk about how we're going to do this problem. Now, in order to do this problem, you have to know what the derivative is. And the derivative is simply the instantaneous rate of change. So when I take the derivative of a function, what I'm essentially doing is I'm finding the instantaneous rate of change at any x value on that curve or on that function. And if you've never heard of this before and you have no idea what I'm talking about, go ahead and check the video below. I'll go ahead and link it. It talks about the difference quotient and where the derivative comes from. But assuming you know how to take the derivative, let's go ahead and talk about how we're going to do this problem. So the first thing that we need to do is we need to find the instantaneous rate of change at any x value on this curve, because that will essentially result in a tangent line, right? That will give us the slope of the tangent line. So what we have to do is we have to take f of x, which we know is really y, right? F of x is really y. And we have to go ahead and take the derivative. So I'm going to say here, I'm going to take the derivative of y in respect to x, right? So dy dx. And this is going to be equal to, well, I have to do the power rule here. When I do the power rule and I take the derivative, I get 4x plus 5, right? So again, this is going to be the instantaneous rate of change. I have 4x plus 5. And again, they want it passing through this point right here, 1, 9 on the curve. So how do I go ahead and do that? Well, the first thing that you have to do is you have to get the actual slope. So at what x value is this tangent line occurring on the curve? And that's going to be at 1. So what I can say here is f prime of x, which is the derivative, right? dy dx, is 4x plus 5. And so if I plug in 1 wherever I see an x, that's going to give me the actual slope of that tangent line passing through that point. So I can say here, slope is equal to 4 times 1 plus 5, which is going to be equal to 9. And from here, you just have to plug it into slope-intercept form. So I have y equals mx plus b. Okay, so we're going to go ahead and plug it in. So what's my x? What's my y? Well, my x and y is right here. X and y, right? So my x is 1, my 9 is y. I'm going to go ahead and plug this in. My y value is 9, so 9 is equal to my slope, which is also 9, and then my x value, which is going to be 1. So 1 and then plus b. So when I do this out, I get 9 is equal to 9 plus b. When I solve for b, I get b is equal to 0. Okay, so putting it all together, I'm going to have y is equal to my slope right here, which is 9. So 9x, and then plus b, well, that's 0. So here's the equation. Y is equal to 9x. Okay, so if you were to graph this function here, and you were to graph this line that we just derived, you would see that it's going to be tangent to that curve, and it would be passing through the point 1, 9. All right, let's go ahead and try another example. So here's our next example. You can see that, again, we're dealing with a quadratic. They want to know what is the equation of the tangent line passing through the point -2, 14 on the curve, okay? So again, the first thing that we need to do here is find the derivative, or in other words, the instantaneous rate of change, because again, that will lead to the slope of the tangent line. So I have to take my y, which is f of x, and I have to go ahead and take the derivative in respect to x. So I'm going to say here dy dx is equal to 10x plus 4. And again, I'm just using the power rule here to get the derivative, right? You should know how to do that if you're on this video. I'm just applying the power rule. And then from here, we can go ahead and get the actual slope of this tangent line. So again, for our x value right here, we want to plug in our -2, because again, that -2 is occurring on the curve, and that's where that tangent line is going to be passing through in regards to the x value, right? So I'm going to say here, f prime of x is equal to 10x plus 4. And then getting the actual slope, I get m is equal to 10 times a -2 plus 4, which is going to be equal to -16, right? I get -20 here, plus 4, I get -16. Okay, so now putting it all together, we have slope-intercept form. I get y is equal to mx plus b. So plugging it in, my y value here is going to be 14. So 14 is equal to the slope that we just got, negative 16. So negative 16. The x value is going to be negative 2. So negative 2. And then plus b. Okay? So again, we're going to solve for b, and then we can put it all together. So I get 14 is equal to positive 32 plus b. And then from here, I just have to do 14 minus 32. And when I do that, I get negative 18. So I'm going to go ahead and put here b is equal to negative 18. Putting it all together, we get y is equal to my slope, negative 16, and then x, and then my b, negative 18. Okay, and that's done. So again, if you were to graph the equation of the line that we just derived here, and then you were to graph this function f of x, you would see that this line right here, negative 16x minus 18, is passing through the point negative 2, 14 on that quadratic, and it will be tangent at that point. Okay, and that is it. So that is how you can find the equation of the line tangent to the curve. It's pretty straightforward. Just remember, you do have to take the derivative because, again, the derivative is the instantaneous rate of change at any x value on the curve. And as a result, that ends up being the slope of the tangent line at any particular point on that curve. Okay, so that is it. I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.